dugsiga boardingka iyo maalinlaha ah ee Amano Boarding and Day School.
Alhamdulillah rabbil alamin, salatu wassalamu ala rasulillah wa ba'du. Assalamu alaykum wa rahmatullahi wa barakatuh. Next week the examination, the third cycle examination will start at 9 May up to 20 May. So various week of examination starts from 9 May to 13 May. So time of examination starts 9 a.m. up to 11 a.m. We continue our topic work done. So this is lesson 5 and also it is a video 5. So 2 times no works done. 2 times no works done. First condition, when you apply a force to a body but that body does not move, no works done. When you apply a force to a body but that body does not move, no works done. So when object does not move, no works done. When a distance is equal to 0, no works done. The second condition, when a force acting, when the direction of motion and the force are perpendicular, no works done. For example, force, this body force is acting downward. Force is acting downward, and the direction of motion is this way. So they are made at 90 degrees. So this is force, and also this is the direction of motion. So when they are perpendicular, no works done. When the direction of motion and the direction of motion, when the direction of motion and also direction of when the direction of motion and direction of the force are perpendicular, no works done. Therefore, we can say, for example, this is earth. For example, this is the earth. This is the earth. So, and also we take this is a satellite. This is a satellite. So satellite revolves around the earth. So this is direction of satellite. It rotates around the satellite, or it revolves around the satellite. So this is the direction of motion. So the direction of motion of satellite is this direction, and also gravitational force is a downward. So they are perpendicular. They are make 90 degrees. So no work is done. No work is done. So work done. So this topic we talk about work done by gravity. Previous lesson we talk about work done by horizontal force, and also work done by a force that makes angle the horizontal. So the third one is a work done by gravity. Work done by gravity. So this work done is done by the gravity. It's done by the gravity. So work done can be found. Work done is equal to force times distance. Force times distance. Therefore, work done is equal to force times distance. Now, distance is the height. Distance is height. Therefore, work done. This force is a force of gravity. Is a force of gravity. Therefore, force of gravity is equal to the weight. Is equal to the weight of body, and the weight of the body can be found mg, and weight of the body is equal to mg, mass times gravity. Mass times gravity. Therefore, this force is a force of gravity, and it is equal to mg, and is equal to mg. So replace where f, replace position of f at mg. So times height. Therefore, work done by the gravity can be found m mass times gravity times height. So that's the formula of work done by the gravity. Work done by the gravity. So work done by the gravity is equal to mass of the body, gravity and also height it is above the ground. Height it is above the ground. Therefore, work done by the gravity, if the body fails a top tower, for example, we have this tower. For example, here is a top tower. For example, when this body fails from this tower above the ground a h at a height, this work done by the gravity, this work done by the gravity, force of gravity. Therefore, when a body fails from a top of a tower, works done by the force of gravity, works done by the force of gravity. Gravitational force is equal to weight of the body, therefore work is equal to Fs, and therefore work done by the gravity is equal to mgh. Example: a man of a mass 70 kilogram climbs stairs of a height 2.5. How much work done? How much work is done? Okay, how much work done? That's the okay. So chi is always constant. Chi is always constant. So first we write solution, and then we write given. Therefore, now we have a mass. Mass is equal to 70 kilogram. Mass is equal to 70 kilogram, and also height it is 2.5 meter, and also chi is constant. Chi is 10 kilogram and 10 meter per second square. 10 meter per second square. Therefore, 10 meter per second square. Therefore, work done by the gravity. Calculate the work done. So this work done by the force of gravity. Therefore, work done by the force of gravity can be found mgh. Work done by the force of gravity is equal to mass is 70 kilogram times gravity. Gravity is 10, and also height it above the ground is 2.5. Therefore, work done by the gravity is equal to we use this calculator. Okay, 70 times 10 times 2.5. It's equal to 1,750. It is equal to 1,750 joule. So unit of work done is a joule. So work done is equal to 1,700 joule. Example 2. A stone of a mass 0.5 kilogram rolls down 50 centimeters low of a height 30 centimeters as a shown figure below. So we have this body. For example, this is a stone. This stone has a mass of 0.5 kilogram, and also we have a height. So we have a height of, this is the length of the slope, but we use the height of the height it is above the ground. Okay, so height is above the ground, it is a 30 meter, and also we have a constant number, gravity it is 10 meter per second square. Therefore, we need work done by the gravity. Therefore, work done by the gravity can be found work done by the gravity mgh. Therefore, work done by the gravity is equal to mass. Mass is 0.5 times gravity, it is 10, height it is 30. 0.5 times 10. 0.5 times 10, it is 5 times 30. Work done. 5 times 30, it is 150 joule. It is 150 joule. Therefore, work done is equal to 150 joule. The next point is energy transferred. Okay. So we already studied the energy's ability to do work. So this lesson we talk about energy transfer. So we have this box. If we apply a virus of F, this body moves a distance of S. It moves a distance of S. So if you apply this body a force, you give energy. You use energy. How much energy is needed to push this box, or how much energy is transferred to this body to move a distance? So the amount of energy is transferred to this box is equal to work done. So we can say energy transferred. Amount of energy transferred to this box transferred is equal to work done. Amount of work done. Know that amount of energy you use, or amount of energy transferred to this body, is equal to amount of work done. Work done is a Fs. Or if you use work done by the gravity, if we take this body, for example, if we take this body from the ground, you transfer energy to it. So the amount of energy transferred to it is equal to amount of work done. Therefore, this box is above the ground at the height of h. So the amount of work done can be found is equal to mgh. Therefore, energy you transfer to the box is equal to amount of work done. Therefore, doing work is a way of transferring energy. Amount of work done is calculated by using Fs, or work done by the gravity mgh. This tells us amount of energy transferred. So work done is equal to energy transferred.